Alexa, will it rain today?
It might rain in Hilton Head Island today. There's a 60% chance. You can expect about 4 millimeters.
This video is on probability, the mathematics of chance. Probability is a value between 0 and 1, showing the likelihood of an event to occur. A probability of 0 means that an event is impossible, and a probability of 1 means an event will occur with certainty. Probability can also be represented as a fraction like 1/2, or a percent like 60%, the chance of rain. Probability has a lot to do with rain. As you see, I'm standing out here in the pouring rain doing a video on probability. Why, you might be asking? Because rain will play a major role in your study of probability, as you will see many questions involving rain on both your tests and practice work. You will also see a lot of questions about marbles, but probability is nothing to lose your marbles over. It has lots of real-life applications in fields like gambling, medicine, and more. Probability isn't just about rain. I mean, like I said, there is a lot of rain in probability, and you will see a lot of rain this year, but probability is not all about rain. In fact, probability, in its first applications, had a lot to do with gambling. As people played games, card games, and those sorts of things, they wanted to determine the odds of winning certain amounts of money or having certain things happen in the game. And there's a lot to do with probability in gambling today, but one of the biggest and most applicable things that comes up a lot is called the gambler's fallacy. And what that shows is basically this. See, I have a coin here, and if I flip this coin, see, I get heads. Now, one would think if I flip it again, the odds of me getting heads is going to be lower because I just got heads, so why would I get heads again? But realistically, these coin flips are all independent events. I can flip it again, and I get tails, which makes sense, but if I flip it again, how likely do you think we are to get heads? Let's see. We get tails again. Now, the gambler's fallacy would show if I flip again, we're going to get heads. But let's see how accurate that is. Remember, these are all independent events, so the chances of me getting heads or tails are 50-50 regardless of how many times I flip. Let's try one last time. And we get tails again. So, as we can see, the probability of me getting heads or tails doesn't really matter how many times I flip the coin. It's still a 50% probability. When you take a multiple choice test like an SAT or an ACT or an AP exam, and a lot of these tests now, you are not penalized for guessing. So it is to your benefit to answer every question. Now the question is, are you more likely to get questions correct if you just start bubbling in C, 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 for example? So you pick a letter, say C, and you bubble in the test C, 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 that one letter you picked all through the test. Or are you more likely to get questions correct by varying the letter you pick? Say you go through the test and you start bubbling in A, B, C, D, and back to A again. So the question is, are you more likely, is your probability higher to get questions correct if you just bubble in one letter? And the answer is yes. An application of probability theory called the law of large numbers shows that you are likely to get more answers correct if you just bubble in one letter, like C. So that may help you if you're running out of time on your AP exam. There's a famous problem in probability theory called the Monty Hall problem, and it's so named because in the 60s and 70s, there was a game show called Let's Make a Deal, hosted by Monty Hall. And on the show, there were different sets and things, ways that contestants could win prizes or money or different things. And one of the sets we're going to talk about today involves 3 doors, 2 goats, and a car. The way it works is this. If I'm a contestant on Let's Make a Deal, and I'm part of this particular setup, I get to choose between one of three doors. Door number 1, door number 2, or door number 3. When I pick a door that I think has the car behind it, because I obviously want to win the car, so when I pick a door that has the car behind it, Monty Hall will open up one of the other two doors. And the door he opens up will have a goat behind it. Monty Hall will never open up a door that has the car behind it. He will always open up a door that has the goat behind it. So he opens up the door because Monty knows which door has the car, which door has the goat. So Monty opens up a door that has the goat behind it. And Monty Hall asks, do you want to keep the door you picked, or do you want to switch to the other unopened door? Now, the probability question is this. If I open up a door, say I pick door number 1, right? And Monty Hall opens up door number 3 and shows that there's a goat behind door number 3. If I pick door number 1, is it better for me to open up door 1? Is it better for me to open up door 2? Is it better for me to switch? Does it make any difference? Or is it a 50% chance, no matter which door I pick? Does the probability of me winning the car not really change? Well, let's see what happens when we try. Let's pretend I'm a contestant here on Let's Make a Deal, and I'm going to pick to open up door number 1. So I opened up door 1, and Monty's showing me that there's a goat behind door number 3. So, should I switch or should I stay? Well, you know what? I think the car is behind number 1. So I'm going to pick number 1. I'm going to open up number 1. And unfortunately, I win a goat. So that's not very good for me. Let's try that again. Let's open up door number 1. And Monty Hall shows me that there's a goat behind door number 2. So let's switch. Let's try door number 3. Let's switch. And I win the car. So I switched to door number 3, and that clearly was the right choice to make because I won the car, not a goat. So let's try door number 2. Let's see what happens. Well, Monty's telling me that there's a goat behind door number 3. Well, I'm going to stick with door number 2. I think the car is behind door number 2. So let's stick with it. And unfortunately, I lost again, because realistically, the car was actually behind door number 1. So let's try number 2 again. And this time, Monty's telling me that the goat is behind door number 1. So let's switch. Let's try number 3. Let's see what's behind 3. And I win again. So I won the car. So that's clearly a good thing, right? So let's try number 3. I think the car is behind number 3. Let's try this. Monty's telling me that the car is not behind door number 2. Well, let's stick with 3. I think it's behind 3. Well, unfortunately, it's not. It's behind door number 1. So let's try again. Let's try door number 3 again. And Monty's telling me it's behind door 2. The goat. Well, let's switch to number 1. Let's switch to 1. And I win. So, clearly, in all 3 cases, and every time we run the simulation, we get different numbers. It just so happened that in all 3 of these simulations we ran, when you switch, you are more likely to win the car. In fact, we won the car 0 times when we stayed, and all 3 times when we switched. So, we had a 100% chance of winning the car. But on this website, there's some data here, and it shows different people that have run the simulation, and it shows what happens when you switch versus when you stay. So on this website here, different people that have run the simulation, it shows that out of the 607 people that opted to switch rather than stay, 407 out of those won the car. So that's a 67.1% success rate. On the other hand, those that chose to stay, 510 people, only 163 of those 510 people won the car by not switching. So that's only a 32% success rate. So clearly, it is better to switch rather than stay. There's a lot of probability in the medical field. Think about surgeries. When a patient is getting a surgery done, they will often ask what the success rate of that surgery is. And some surgeries might have different probabilities that the patient will survive and different probabilities that the treatment is going to work. So it's all about when you hear that a surgery has, say, a 95% chance of success or a 95% success rate, that data was determined, it's a probability of success, and it was determined based on surgeries that have been performed for clinical trials or other people that have had the surgery done. So when you're talking about probabilities of success or success rates, that is a real-life application of probability. Think about insurance companies. Their whole business model revolves around probability. I mean, if you are a insurance company, say you're a car insurance company, and you are providing insurance policies to people, you're charging a monthly premium for that insurance, and you hope that no one crashes their car. But realistically, some people are going to crash their car. So you, as an insurance company, have to work out the probability that the policy that you are giving to someone will not be collected on. And insurance companies have different ways of determining that. I mean, if you have two drivers, driver A and driver B, say, and driver A has a long history of traffic tickets and things of that nature, and driver B has never had one in 5 years, obviously driver B is a better driver and probably won't crash as frequently or as often and won't be as high a risk for an insurance company. So insurance is all about probability. What is the risk that the person that I'm going to insure is going to collect on this policy? And that's why insurance rates for different people differ. From goats behind closed doors to multiple choice testing, probability has lots of real-life applications. It's probable that you'll enjoy your study of probability. I think the probability of your enjoyment of probability is certainly greater than 0 if you're still watching this video. I studied probability, and as you see, I still have my marbles. Don't let probability make you lose yours.